Hello friends, welcome to my channel. So in this video we are going to see the various types of cement. So first, rapid hardening cement that we have covered in the last video. So we will move forward with the remaining types of cements. So this is our second type of cement, that is low heat cement. So it is completely opposite of the rapid hardening cement. Now we have learned about the box compound, how to arrange the box compound to attain the early strength or latter strength. So on the basis of that, directly we will write the composition of the low heat cement here. So to achieve the low heat cement, whatever the proportion of tricalcium silicate and tricalcium aluminate is kept in the lower grades or lower content, as both are responsible for the early strength or early heat of hydration. So the content of tricalcium silicate and tricalcium aluminate we kept in the lower quantity. And as we know that dicalcium silicate, which is responsible for the latter strength, which is generally occurs after the 7 days, so the dicalcium silicate proportion in the case of low heat cement, it is kept in the increased order. Okay, now we will see the property of low heat cement. So obviously its name indicates it's low heat cement, so that means it gives the less heat of hydration. Okay, so less heat of hydration. Then its second property, that it gives high durability. Okay, high durability. Then we will see its uses. Okay, so first use, it is used in the mass concreting. Okay, it is used in the mass concreting because in the mass concreting the heat generation of heat of hydration is quite high. To avoid that, we use the low heat cement in case of mass concreting. Example of mass concreting, we can give it as a dam structure, dam structures. And the second use, it is used in the hot weather concreting. Okay, used in a hot weather concreting, hot weather concreting. So hot weather concreting, it is the working environment when we work in the above 40 degrees Celsius, then it is termed as the hot weather. Now we will talk about one more property, that is setting times. Okay, so setting time is as same as OPC. So setting time, first one, initial setting time, it is same as OPC, that is 30 minutes, and final setting time, it is of the 10 hours or 600 minutes. Okay, because as we know that, as we learned in the last video, what is the difference between setting and hardening. Once again we revise here. Setting is just change in the fluid or paste form into the solid form in the cement, that is called setting of the cement. And in the hardening, along with the solid state, it start gaining the strength. Okay, so that does not allow to change the setting time of the low heat cement. So low heat cement gives the same setting time as ordinary Portland cement gives. So this is all about the low heat cement. Our third type, that is sulfate resisting cement. So in the sulfate resisting cement, the composition that we kept of the box compound, so tricalcium silicate, it is came in the higher proportion, and then tricalcium aluminate are in the lesser proportion or lesser content. In case of sulfate resisting cement, we kept aluminates in the less quantity. The reason of keeping aluminates in the less quantity is to avoid the sulfate reactions. Okay, so aluminate are in the less quantity because to avoid sulfate reactions. Okay, reaction. So this is about the box compound arrangement. Then the sulfate resisting cement, the next property is about its initial and final setting times. So its initial setting time is 20 minutes. It's 20 minutes, and final setting time is same as OPC. Final setting time is same as OPC, that is 10 hours. Okay, then we will see the uses of sulfate resisting cement. So its uses, so it is used in the underwater structures. the underwater structures. And second use, it is used against the alkali actions. Okay, so we can write as it gives resistance against alkali action. Okay, alkaline action. So it is used where we have to suffer against the alkali, and in the water structures the sulfate attacks are most, so sulfate resisting cement it is advisable to use in the underwater structures. Okay, so this is about the sulfate resisting cement. Now we will move towards the next type. So it is blast furnace slag cement. So in the blast furnace slag cement, as its name indicates, the main constituent or ingredient used is a blast furnace slag. So the basic proportion we kept to manufacture the blast furnace slag cement, that is OPC clinker. Okay, OPC clinker along with the blast furnace slag. Blast furnace slag. Okay, so what is the percentage that we kept to manufacture the cement? OPC around 35% and remaining 65% it is of the blast furnace slag. Okay, so this is the basic proportion we kept to manufacture the blast furnace slag cement. Now we will see some properties of the blast furnace slag cement. So the first property, it delivers the low heat of hydration. The next property, it is highly durable. Okay, so it gives the high durability. And the next property that it gives or delivers is it gives resistance against sulfate and alkali actions. Okay, so it gives resistance against sulfate and alkali actions. Now we will see its uses. Okay, so its uses. So as we know that it gives the resistance against sulfate attacks alkali actions, so it is useful in the marine structures. Okay, in the marine structures. And its setting times, so it is same as OPC. That means its initial setting time is 30 minutes and final setting time is of the 10 hours. Okay, so final setting time 10 hours or 600 minutes. So this is all about the blast furnace slag cement.